What if everything we know about energy and heat in our solar system is a lie? For 50 years, the laws of thermodynamics told us that a giant planet should behave like a massive thermal battery, storing the primordial heat of its birth for billions of years. But those laws have been shattered. New 3D mapping from the James Webb Space Telescope has just confirmed a terrifying thermal collapse. The Uranian upper atmosphere isn't just cold, it's crashing at a rate that defies every model we have. Since the 1990s, the temperature of its thermosphere has plummeted, and as of this week, JWST has clocked a record-breaking low near 150 degrees Celsius. While the public is being told this is just a slow seasonal change, internal data suggests a high-stakes crisis. The energy isn't just dissipating, it's vanishing. Some researchers are now pointing to dark depletion zones, massive energy-leaking voids that suggest the planet is being actively drained of its internal power. Is Uranus simply a frozen wasteland, or is something deep within the planet's structure acting as a heat sink, pulling energy away from the surface and into a void we can't see? Today, we reveal the data that NASA can no longer explain. Uranus has always been the outlier. It is the only planet in the solar system that is fundamentally broken by every standard metric of planetary physics. When the Voyager 2 spacecraft flew past in 1986, it sent back data that left the scientific community in a state of shock. At that time, the planet's thermosphere was measured at a staggering 750 Kelvin. To put that in perspective, that is roughly 475 degrees Celsius. For a world that is nearly 2 billion miles away from the sun, that heat shouldn't exist. There isn't enough solar radiation reaching that far out to keep an atmosphere that energized. For decades, this was known as the Uranus energy crisis. Scientists spent 40 years trying to find the invisible heater that was keeping the seventh planet alive. They proposed everything from gravity waves to auroral heating, but nothing quite fit the math. But then, the James Webb Space Telescope turned its infrared eye toward the planet in 2024 and 2025. And what it found was the exact opposite of what we expected. Instead of finding the source of the heat, Webb found that the heat was gone. In the span of just a few decades, the temperature of the Uranian thermosphere has halved. It has dropped from 750 Kelvin to just over 400 Kelvin. That is a 300-degree loss in the blink of a cosmic eye. This isn't just cooling, this is a thermal freefall. The latest study, led by researchers at Northumbria University and released this month, utilized JWST's near-infrared spectrograph. In IR-SPEC, they mapped the planet for a full rotation and confirmed that the atmosphere is still cooling at a relentless rate of roughly 8 Kelvin per year. This brings us to the first major anomaly. In any other planetary system, a temperature drop of this magnitude would take millions of years. On Uranus, it is happening in real time. We are watching a giant planet lose its vitality faster than physics allows. The energy is vanishing, and for the first time, we have the 3D maps showing exactly where it is leaving the system. To understand where the heat went, we have to look inside. We have to look at what scientists are calling compositional convection. In a healthy giant planet like Jupiter, the interior is a churning engine. Hot material from the rocky core rises up, and cold material from the clouds sinks down. This constant circulation, convection, transports heat to the surface and keeps the planet glowing in the infrared spectrum. But the 2026 models from the University of Zurich suggest that Uranus is stratified. It is layered like oil in water. Deep within the mantle, there are massive layers of ionic water and heavy silicates that simply do not mix with the hydrogen and helium above them. These stagnant zones act like physical thermal blankets. They are so dense and so stable that they trap the primordial heat of the core in a basal magma ocean thousands of miles deep. The heat is physically locked away. It is trapped in a dungeon of high-pressure ice. Because this internal heat cannot rise to the surface, the upper atmosphere is left exposed. It is stranded on the edge of the void with no power source to keep it warm. The planet isn't cooling down because its core is dead. It's cooling down because the surface has been physically cut off. This creates what astrophysicists call a cold trap. Without the internal heat to push back against the vacuum of space, the atmosphere begins to condense and collapse. And this is where the James Webb data gets truly terrifying. JWST has identified the smoking gun of this energy crisis, the dark depletion zones. These are specific regions in the ionosphere mapped in 3D for the first time this month, where ion density and infrared emissions are almost zero. On Earth, our magnetic field protects us from the solar wind. It acts like a shield, deflecting charged particles around the planet. But as we know, the magnetic field of Uranus is a mangled wreck. It is tilted at 60 degrees and offset from the center of the planet. Instead of a shield, Uranus has a series of magnetic funnels. These dark depletion zones are literal thermal exhaust ports. They are areas where the chaotic magnetic field is stripping charged particles out of the atmosphere and dragging energy away into the void. The 2026 data shows that Uranus is uniquely sensitive to the solar wind. When the solar wind pressure declines, as it has been intermittently over the last decade, Uranus reacts violently. It is the only planet whose temperature is governed more by the solar wind than by the sun itself. Think about that for a second. A planet whose very temperature is at the mercy of the weather in deep space. If the solar wind changes, the planet's thermal armor fails. And right now, the armor is failing across the entire northern hemisphere. This brings us to the great 2028 solstice. We are now in a race against time. In just 2 years, the North Pole of Uranus will point directly at the Sun for the first time in nearly a century. This should be the moment the planet finally warms up. Standard physics dictates that as solar radiation hits the pole head-on, the atmosphere must absorb that energy and heat back up. This is how seasons work. This is the fundamental rule of planetary motion, but the JWST tracking data shows the cooling trend hasn't stopped. It hasn't even slowed down. If the temperature continues to crash, even as the planet reaches its point of maximum solar exposure in 2028, it will prove that our understanding of planetary energy is fundamentally broken. It would mean that internal stratification and solar wind stripping have completely overridden the power of the sun. We would be witnessing the birth of a new kind of world, a world that is dead on the surface while being a pressure cooker on the inside. This isn't just a problem for Uranus, it's a problem for our understanding of the entire galaxy. As of 2026, we know that the most common type of planet in the Milky Way isn't a rocky Earth or a gas giant Jupiter. It is the sub-Neptune or ice giant. If the seventh planet is currently breaking the laws of thermodynamics, it means thousands of exoplanets out there are doing the same thing. Our models of habitable zones are based on the idea that planets behave predictably. Uranus is proving they don't. We have to ask the question, why is this happening now? Why did the cooling accelerate so sharply in the last 5 years? Is it just a coincidence that this thermal collapse aligns with the discovery of new moons and active polar cyclones, or is something else going on? Some researchers have pointed to the second core theory, the idea that a massive, undigested impactor world is still sinking through the mantle, causing these layers to stay stagnant and blocking the heat flow. If there is a ghost core inside Uranus, it is acting as the ultimate heat sink. It is absorbing the planet's vitality and locking it away where we can't see it. It is a planetary parasite, starving the atmosphere of the energy it needs to survive. The implications for future exploration are massive. NASA has already been discussing a dedicated Uranus Orbiter and Probe (UOP) mission for the 2030s. But the 2026 data suggests we might not be visiting the same planet Voyager saw in 1986. We are heading toward a world that is colder, more active, and more magnetically chaotic than anything we previously imagined. A world that is bleeding its atmosphere into space through dark voids that shouldn't exist. If you want to keep tracking the anomalies they can't hide, hit that like button and subscribe so you never miss a reveal. We are monitoring the JWST data feeds daily, and the 2028 solstice is coming faster than you think.